Good morning. Here you can see the topic Saturn can float on water. It sounds astonishing that how is that possible that Saturn can float on water. We know that Saturn is the second largest planet in our solar system. The largest one is Jupiter and the second largest is Saturn. Yes, it is larger than our planet Earth. Still, it can float on water. How is that possible? That is the question. You know that airplane or aeroplane, helicopters, means aircrafts, can float on air. All these things means all the aircrafts are made of metals. Okay. And you know that all the metals are having the density greater than the density of water. Still, they can float in air. Similarly, Saturn also can float on air, on water. Not air, I am not talking about air. Here it is water. Okay, you can see the topic. It is water. Question is, if you take the example of iron, you know that 7.8 gram per cc, that is the density of iron, 7.8 gram per cc, or 7,800 kg per cubic meter, almost like that, okay, 7800 kg per cubic meter. This is the density of iron. This is the density of iron. Okay. And density of water, that is H2O, it is how much? It is 1000 kg per cubic meter. So you can see that density of iron is more than the density of water. It is 7.8 times heavier. Iron is 7.8 times heavier than water. You can see. Okay. So, if you take a piece of metal, say a rectangular piece of iron, and if you keep it on the surface, free surface of water, you will simply observe that it is immersed. The iron plate is immersed. Okay. But if you take the same metal, that is the iron, and by using that iron, you make a hollow sphere. Okay. And now you put it on the surface of free water. On the free surface of water. Okay. On the free surface of water, then in that case you can observe that it is floating on the surface of water. Of course, some part of the metallic sphere will go inside the water and some part will be above the water. That means it is floating. Okay. So, what is the difference? In the first case where there was a rectangular plate of iron, and in the second case it is a hollow sphere of the same metal. So, where is the difference? Difference lies in the average density. Okay, difference lies in the average density, not the density of the metal, but the density of the entire volume. Whenever you are taking the hollow sphere of iron, the average density is less than the density of iron, and even it is less than the density of water. It becomes less than the density of water whenever you are taking the hollow sphere. In that case, we are not talking about the density of the iron. In that case, we are talking about density of the total volume, of the entire volume. Okay. So, now I think you can understand the difference. Okay. So, similarly, Saturn no doubt Saturn is larger than Earth. Okay, it is the second largest planet in our solar system. But if you calculate the average density of Saturn, you will find that it is well below the density of water. That is, the numerical value of that density will be less than 1000 kg per cubic meter. So it is possible that Saturn can float on water, though on the surface of our planet Earth such huge body of water is not available. Okay, because volume of Saturn is more than the volume of Earth. But if such large body of water is available, then Saturn can easily float on that water. And one thing you should keep in your mind that Saturn, that planet, is made up of mostly gas. Okay, so obviously density of that planet is less than the density of water, and so Saturn can float on water. This was the explanation. Okay, it does not depend upon the total mass, it does not depend upon the total volume, it depends upon the average density. It means what? Whether that object can float on water or not, that depends upon the average density and nothing else. Okay, do not consider the total volume, do not consider the total mass. You consider only, yes, for the calculation of average density, mass is required, volume is required. Okay, but the numerical value of average density, that is required. By considering that average density, you can easily decide that that object can float on given liquid or gas or not. Okay, that is the actual answer. Okay, so this is the end of this lecture. Thank you for watching this video. Have a nice day.